One of the distinguishing features of Java initially was the ability to consciously and programmatically handle errors. Not that other languages didn't necessarily have it. Java has a very strong requirement of you as a programmer to be aware of the errors that are available, that are possible, that you might be causing as a programmer, and to deal with them programmatically. And so what are we talking about when we say errors? We're not talking about everything in the world. Software is not always safe, but we're not worried about things like viruses and hacking and big problems like that. We're much lower level. We're talking about issues that we can control in code. So things that users do badly, hardware that might go wrong, things that programmers might miss as they're doing their programming. We'll talk about this more as we go. So just want to set that context. We're talking about little things that happen inside of our application. This is not cybersecurity here. This is just basically fundamentally building quality software. So exceptions describe the occurrence that just happened. When we hear the word exception, it's an event. It's something that happened where I divided by 0, or something where I'm looking through a list and I went through too many items in the list. There was 10 items in the list. I'm asking you to show me number 11. That doesn't exist. So the exception object that we're going to be talking about captures that information, captures that data, and so it describes the problem and gives us a chance to go off and fix the problem. And so that's the key way we can identify problems in our software and then plan out what we're going to do in response. So the exception itself is something that really shouldn't exist. I mean, if we write good software, if we test it appropriately, ideally we would be taking everything out. But when we do our testing, we find only some of the problems that happen, and we can't deal with all the real-world problems that happen along those lines. So real-world errors are things like environmental issues. The hard drive has a bad sector. The internet's no longer available. We can't read or write a file because it's either locked by somebody else or marked read-only, or again, part of that bad sector. And then those stupid users outside of there, they do things like we ask to type in your age and they type in some text there instead. Well, that's not what we were expecting, and so it's going to cause problems in our software, but we can handle that because we have exception handling. And to be fair, we can throw in programmer mistakes too. We forgot to do a test case. We had some flow we didn't expect it to even be part of the test case, or we just modeled data badly and messed up. We should get those things in testing, but sometimes they do leak through. So the way we describe an exception in Java is using some class that's part of this exception hierarchy. There's actually a bigger hierarchy, but we talk about exceptions. There's the throwable hierarchy, but nobody talks about handling throwables. We talk about handling exceptions. So everything in Java is an object. It's an object-oriented language, and so exceptions are, all puns intended, no exception. And the base class for that is the exception class. So anything that extends from the exception class, or actually the throwable class, becomes an exception. But we, as Java programmers, typically only extend out of this exception class here because that's part of the hierarchy that we're supposed to extend from. It's supposed to be creating modeling errors that we have created and controlled. So looking at that hierarchy here in a little bit more detail, and there's way more detail you can talk about, the exception hierarchy for us is this bottom half. The top half here is errors, which are things that are like those hardware machine errors, virtual machine errors. We're out of memory, Stack Overflow, things that are outside of our control. We don't typically add on to this when we create new exceptions, new errors, new error conditions, because we're not creating new hardware errors that are out there. In theory, you could, but it's really, really unlikely. So we deal at this bottom half of the exception hierarchy. And so you have things like I/O exceptions, file not found, SQL exceptions. Your query was bad to the database you're trying to query. And then this runtime exceptions, which are everyday occurrences that could go wrong. And this is an important difference right here. So the idea of a runtime exception is it's things that absolutely you could do. Every time you index into an array, you could get an index out of bounds exception. But it's so common, you don't think about it. Every time you take a step walking, you could fall down. But it's not like you're constantly, well, it's what you do with old people. You give them a walker, so they're constantly guarded against falling down. That's the same sort of thing here. We could make you, every time you did math, check for divide by 0, but we're not going to, because that means you'd be handling exceptions all over the place, but things that we do less commonly, like access a database, are required to deal with exceptions, deal with the exception hierarchy. And that's why it's important to model our exceptions so we know the ones that are likely to happen, because there's stuff outside of our control, and things that it could happen, but mostly we test to make sure they don't happen. So when an exception happens, we create an object to represent that exception. So like an arithmetic exception happens, we have information such as what's the thread of the occurrence, where in the program did it happen, what's the call tree, what method called which method, which called which method, and then there's some text that describes it and possibly some additional values such as a number that says the arithmetic exception is you were trying to work with this number and it's a bad number inside of there. And so that is built up through this exception hierarchy. There's part that's a throwable, there's part that's exception, part that's runtime exception, and it builds that up. So you'll learn more about inheritance as you go learn more about Java, but just remember that these pieces fall into it, and there's parts of this exception hierarchy all over the place. And so all of these top things are part of every exception, every error. We know where it happened in our program, and there's specific characteristics that come from other places in the hierarchy that we're going to learn about, because we want to be really specific in our exceptions to be able to do something with them intelligently later on, or at least report to the programmer, saying this is what's going on that's wrong. And so, as I mentioned before, it's important to distinguish between exceptions and errors. Errors are things that are outside of our control. They could happen on any line of code because they just happen. Anything that accesses the hard drive could cause a hard drive reading error. If the RAM of the program, of your computer goes bad, any operation could do it, completely unrelated to what code you were happening at that point. And so errors could happen just because you happen to be running code at that moment, and so you're not required to deal with those. You can deal with those at any point you want to. You can try and respond gracefully to these cases, but those are typically done at a very high level in programs and in one or two spots to deal with those unpredictable things. Exceptions, then, are the failures that we would expect to have happen. And so anytime the risk of an exception is there, is something you have to deal with. So you have to, anytime there's an exception, either IO exception or SQL exception, or we'll see lots of different examples as you go and program Java. Those are things you must be aware of and must deal with. Now, within that, the exception to the rule, the special case, is that runtime exception we talked about, which the runtime exception means it's so common we're not going to make you deal with that. And so remember that hierarchy. It's not really important. You're not going to be asked to create any new exceptions anytime soon. It's very uncommon. I've been working in the field for 20 years. I've probably built, 15 or 20 custom exceptions, maybe one a year, probably less than that over time. They're useful, they're valuable, but the amount of exception handling code I've written, that happens all the time. And so by modeling the exceptions, we can create a very good definition of what they are. By fitting into this hierarchy, we can say what type of error it is. Am I dealing with I/O? Am I dealing with a database? Am I dealing with a network? Am I dealing with, perhaps image handling or something like that? When I was working with a credit card, we created a service to deal with credit cards. We had specific exceptions we would create, say, you have exceeded your limit on the credit card exception. There's different reasons you might create things like that as part of the service, but there's also reasons why you can work around that. We'll talk about that later as well. And so now that we understand how to model them, it doesn't mean that we fix them. So the first step is we need to understand what went wrong, and then later on we can do something about it. And that's what the next video is going to talk about, is how do we handle these exceptions.